We've already seen that the fraction 2/5, or a fraction like the fraction 2/5, can be literally represented as 2 times 1/5. 2 times 1/5, which is the same thing, which is equal to literally having 2 1/5. So 1/5 plus 1/5. And if we wanted to visualize it, let me make a whole here and divide it into 5 equal sections. And so this represents 2 of those fifths. This is the first of the fifths, and then this is the second of the fifths. Literally 2/5, 2/5, 2/5. Now let's think about something a little bit more interesting. What would 3 times 2/5 represent? 3 times 2/5. And I encourage you to pause this video and based on what we just did here, think about what you think this would be equivalent to. Well, we just saw that 2/5 would be the same thing as, so let me just rewrite this as instead of 3 times 2/5 written like this, let me write 2/5 like that. So this is the same thing as 3 times 2 times 1/5. 3 times 2 times 1/5 times 1/5. And multiplication, we could multiply the 2 times the 1/5 first and then multiply by the 3. Or we could multiply the 3 times the 2 first and then multiply by the 1/5. So you could view this literally as being equal to 3 times 2 is, of course, 6. So this is the same thing as 6 times 1/5. 6 times 1/5. And if we were to try to visualize that again, so that's a whole, that's another whole. Each of those wholes have been divided into 5 equal sections. And so we're going to color in 6 of them. So that's the first fifth, second fifth, third fifth, fourth fifth, fifth fifth, and that gets us to a whole. And then we have 6/5, just like that. So literally 3 times 2/5 can be viewed as 6/5. And of course, 6 times 1/5, or 6/5, can be written as, so this is equal to literally 6, let me do the same color, 6/5. 6 over 6 over 5. Now you might have said, well, what if we, instead of viewing 2/5 as this, as we just did in this example, we view 2/5 as 1/5 plus 1/5. What would happen then? Well, let's try it out. So 3 times 2/5, I'll rewrite it. 3 times 2/5, 2 over 5, 2/5, is the same thing as 3 times 1/5 plus 1/5. 2/5 is the same thing as 1/5 plus 1/5. So 3 times 1/5 plus 1/5, which would be equal to, well, I just have to have literally 3 of these added together. So it's going to be 1/5 plus 1/5 plus 1/5 plus 1/5 plus, I think you get the idea here, plus 1/5 plus 1/5. Well, what's this going to be? Well, we literally have 6/5 here. We could ignore the parentheses and just add all of these together. We once again have 1, 2, 3, 4, 5, 6/5. So once again, this is equal to 6/5. So hopefully this shows that when you multiply that 2/5 we saw already represents 2 1/5. We already saw that, or 2 times 1/5. And 3 times 2/5 is literally the same thing as 3 times 2 times 1/5. And in this case, that would be 6/5. So we have here, it says 2 times 4/3 is equal to 8 times blank. And what I encourage you to do is pause the video right now and try to think about what should go in this blank. So I'm assuming you've given your try. Now let's think through this. So 2 times 4/3, we can literally view that as the same thing as, if we rewrite the 4/3, this is the same thing as 2 times, instead of writing 4/3 like this, I'm literally going to write it as 4/3. And I know it sounds like I just said the same thing over again, but I'm literally going to write 1/3 4 times. 1/3 plus 1/3 plus 1/3 plus 1/3. This is literally, if you call each of these a third, there you literally have 4 of them. This is 4 thirds. 2 times 4 thirds is the same thing as 2 times literally 4 thirds. Now, what would this be? Well, this is going to be equal to, let me just copy and paste this. It's going to be this 2 times. So copy, and then let me paste it. So that's one group of those 1/3 of those 4 1/3, or one group of one of these 4 thirds. And then we'll have another one. And then we'll have another one, and we're going to add them together. That's literally 2 times 4 thirds. So let's add these together. Now what do we have? Well, we have a bunch of thirds, and we need to count them up. We have 1, 2, 3, 4, 5, 6, 7, 8 thirds. This is literally equal to, and we could, just to make it clear what I've just done, we could ignore the parentheses and just add up all of these things together. So that might make it a little bit clearer. So let me do that. Just to make it clear that I literally I've taken 8 1/3 and I'm adding them together, which is the exact same thing as 8 thirds. So let me clear that, and let me clear that. Let me clear that. And so this is literally, or this is clearly, or hopefully clearly, equal to, this is equal to 8 times 1/3. I have 8 1/3 there. So going back to the original question, what is this equal to? 2 times 4 thirds is the same thing as 8 times 1/3. And we've already seen that 8 times 1/3, well, that's literally 8 thirds. So we could also write it like this, 8 over 3. Let me do that 3 in that other color. 8 over 3. We have 3 expressions here. This is 2 thirds times 7/8. The second expression is 8 sevenths times 2 thirds. This third expression is 5 times 2 over 3 times 5. And what I want you to do is pause this video right now and think about which of these expressions is the largest, which one is in the middle in terms of value, and which one is the smallest. And I want you to think about it without actually doing the calculation. If you could just look at them and figure out which of these is the largest, which of these is the smallest, and which of these is in the middle. So pause the video now. Now you might have taken a shot at it, and I'll give you a little bit of a hint in case you had trouble with it. All of these involve multiplying something by 2 thirds, and you see a 2 thirds here, you see a 2 thirds here, and it might not be as obvious, but you also see a 2 thirds here. And let me rewrite that to make it a little bit clearer. So this first expression could be rewritten as 7 over 8 times 2 thirds. This second expression here could be written as, well, it's already written as 8 over 7 times 2 thirds, And then this last expression, we could write it as, in the numerator, 5 times 2, and then in the denominator, it's over 5 times 3. 5 times 3, which is, of course, the same thing as 5 over 5 times 2 thirds. So you see all 3 of these expressions involve something times 2 thirds. Now looking at it this way, does it become easier to pick out which of these are the largest, which of these are the smallest, and which of these are someplace in between? I encourage you to pause it again if you haven't thought about it yet. So let's visualize each of these expressions by first trying to visualize 2 thirds. So let's say the height of what I'm drawing right now, let's say the height of this bar right over here is 2 thirds. So this right over here represents 2 thirds. The height here is 2 thirds. So first let's think about what this one on the right here represents. This is 5 over 5 times 2 thirds. Well, what's 5 over 5? 5 over 5 is the same thing as 1. This is literally just 1 times 2 thirds. This whole expression is the same thing as 1 times 2 thirds, or really just 2 thirds. So this, the height here, 2 thirds, this is the same thing as this thing over here. This is going to be equal to, this could also be viewed as 5 times 2 over 3 times 5, which was this first expression right over here. Now let's think about what these would look like. So this is 7/8 times 2 thirds. So it's less than 8/8 times 2/3. It's less than 1 times 2/3. So we're going to scale 2/3 down. This is going to be less than 2/3. It's going to be 7/8 of 2/3. So this one right over here, would look something like this. Would look something, let me see if I could draw it. Yeah, it would look something like this. If the yellow height is 2/3, then this right over here, then this height right over here, let me make it clear, this height right over here would be 7/8 times 2/3. Likewise, let's look at this one right over here. Let's look at this one in the middle. 8/7 times 2/3. Well, 8/7 is bigger than 7/7. It's more than 1. This is more than 2/3. This is 1 1/7 times 2/3. So it's going to be the same height as 2/3 plus another 7th. So it's going to look something like this. It's going to look something like this. So its height, now we scaled the 2/3 up, because 8/7 is greater than 1. So this right over here, this height is going to be 8/7 times 2/3. So the way that you could have spotted which of these is the largest and which of these is the smallest is to say, well, how are they scaling 2/3? This one right over here, you're essentially multiplying 2/3 by 1. So you're just going to get 2/3. You're not scaling it up, or you aren't scaling it down. This one right over here, you're scaling 2/3 down. You're multiplying it by something less than 1. If you multiply it by something less than 1, then you are going to be scaling it down. I should say a positive number, or a number between 0 and 1, less than 1, then you're going to be scaling it down. So this thing is scaled down. It's going to be the smallest. And here you're multiplying the 2/3 times a number bigger than 1 by 1 1/7. So you're going to scale it up. So this expression is the largest, 8/7 times 2/3. The smallest is 2/3 times 7/8. And this one right over here is in between. Let's think about what it means to multiply 2/3, or 2/3, times 4/5 times 4/5. In a previous video, we've already seen how we can actually compute this. This is going to be equal to, in the numerator, we just multiply the numerators. So it's going to be 2 times 4, 2 times 4. And in the denominator, or we just multiply the denominator. So it's going to be 3 times 5. 3 times 5. And so the numerator is going to be 8, and the denominator is going to be 15. And this is about as simple as we can make it. 8 and 15 don't have any factors common to each other than 1. So this is what it is. It's 8/15. But why does that actually make sense? And to think about it, we'll think of two ways of visualizing it. So let's draw 2/3. So let's draw 2/3. I'll draw it relatively big. So I'm going to draw 2/3, and I'm going to take 4/5 of it. So 2/3, I'm going to make it pretty big. 2/3, 2/3, just like this. So this is 1/3, and then this would be 2/3. Actually, I could do a little bit better job making those equal, or at least closer to looking equal. So there you go. I have thirds. Let me do it one more time. So here I have drawn thirds. 2/3 represents 2 of them. It represents 2 of them. And one way to think about this is 2/3 times 4/5 is 4/5 of this 2/3. So how do we divide this 2/3 into fifths? Well, what if we divided each of these sections into 5? So let's do that. So let's divide each into 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I could even divide this into 5 if I want. 1, 2, 3, 4, 5. And we want to take 4/5 of this section here. So how many fifths do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we got to be careful. These really aren't fifths. These are actually 15ths, because the whole is this thing over here. So I should really say how many 15ths do we have? And that's where we get this number from. But you see, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Where did that come from? I had thirds, and then I took each of those thirds and I split them into fifths. So then I had 5 times as many sections. 3 times 5 is 15. But now we want 4/5 of this right over here. So we have, this is 10/15 right over here. Notice that's the same thing as 2/3. Now if we want to take 4/5 of that, 4/5 of, if you have 10 of something, that's going to be 8 of them. So we're going to take 8 of them. So 1, 2, 3, 4, 5, 6, 7, 8. We took 8 of the 15. So that is 8/15. You could have thought about it the other way around. You could have started with fifths. So let me draw it that way. So let me draw a hole. So this is a hole. And let me cut it into 5 equal pieces, or as close as I can draw 5 equal pieces. 1, 2, 3, 4, 5. 4/5. We're gonna shade in 4 of them. It's 4 of the 5 equal pieces. 3, 4. And now we want to take 2/3 of that. Well, how can we do that? Well, let's split each of these 5 into 3 pieces. So now we have essentially 15ths again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we want to take 2/3 of this yellow area. We're not taking 2/3 of the whole section. We're taking 2/3 of the 4/5. So how many 15ths do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you have 12 of something and you want to take 2/3 of that, you're going to be taking 8 of it. So you're going to be taking 1, 2, 3, 4, 5, 6, 7, 8. Or 8 of the 15ths now. So either way, you get to the same result. So one way, you're thinking of taking 4/5 of 2/3. Another way you could think of it is you're taking 2/3 of 4/5. Let's think a little bit about what it means to multiply fractions. Say I want to multiply 1/2 times 1/4. Well, one way to think about this is we could view this as 1/2 of a fourth. And what do I mean there? Well, let me take a whole. Let me take a whole here. And let me divide it into fourths. So let me divide it into fourths. So I'll divide it into 4 equal sections. And so 1/4 would be one of these 4 equal sections. But we want to take 1/2 of that. So how do we take half of that? Well, we could divide this into 2 equal sections and then just take one of them. So divide it into 2 equal sections and then take one of them. So we're taking this pink area is 1/2, and we're going to take, or sorry, this pink area, this whole pink area is 1/4, and now we're going to take half of it. We're now going to take half of it. So that's this yellow square right over here. But what fraction of the whole does this yellow represent? Well, it now represents 1 out of 1, 2, 3, 4, 5, 6, 7, 8 equal sections. So this right over here represents 1/8 of the whole. And so we see conceptually that 1/2 times 1/4, it completely makes sense that 1/2 of 1/4 should be 1/8. And it hopefully makes sense that you get this 8 by multiplying the 2 times the 4. You started with 4 equal sections, but then you divided each of those 4 equal sections into 2 equal sections. So then you have 8 total equal sections that you split your whole into. Let's do another example, but now let's multiply 2 fractions that don't have 1s in the numerator. So let's multiply 2/3 times 4/5. And I encourage you now to pause the video and do something very similar to what I just did. Try to represent 4/5 of a whole, and then try to represent 2/3 of that 4/5 and see what fraction of the whole you actually have. So pause now. So let's think about this. Let's represent 4/5. So if I have a whole like this, let me try to divide it into 5 equal sections. 5 equal sections. So let's say that is 1 equal section, That is 2 equal sections. That is 3, 4, and 5. I can do a better job than this. This is always the hard part. I'm trying my best to make them look at least like equal sections. 2, 3, 4, and 5. I think you get the point here. I'm trying to make them equal sections. And we want 4/5. So we want 4 of these 5 equal sections. So this would be 1 of the 5 equal sections, 2 of them, 3 of them, and then 4 of them. So that right over there is 4/5. Now we can view this as 2/3 of the 4/5. So how can we think about that? Well, we could take this section and divide it into thirds. So let's do that. Divide it into thirds. So we're going to divide it into 3 equal sections. So that's 1/3 and then 2/3. So we took each of the 5 equal sections and we divided them into 3 equal sections. Now what's going to be 2/3 of the 4/5? Well, that's going to be this part right over here. So let me make this clear. This is 1/3 of the 4/5, and then if we could, this would be 2/3 of the 4/5. So this right over here would be 2/3 of the 4/5, or 2/3 times 4/5. But what fraction of the whole does that represent? Well, how many total equal sections do we now have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 equal sections. Let me do this in a new color. We have 15 equal sections, and that makes sense. We started with 5 equal sections, but then we divided each of those into 3 equal sections. So now we have 5 times 3 total equal sections. And then how many of those are now colored in? Well, we see it's 2 times 4. 1, 2, 3, 4, 5, 6, 7, 8. Or how many of them are in the 2/3 of the 4/5, I should say. And there's 8 of them. 8 of the 15 equal sections. And so there you have it. It should hopefully now make visual sense, or it makes conceptual sense, that 2/3 times 4/5, you can obviously compute it by just multiplying the numerators. 2 times 4 is 8, and then multiplying the denominators. 3 times 5 is 15. But hopefully this now makes conceptual sense as 2/3 of 4/5. In a previous video, we saw that we could view 2/3 times 6 as whatever number is 2/3 of the way to 6 on the number line, which we saw as 4. Or another way to think about it is that 4 is 2/3 of 6. 2/3 times 6 can be viewed as, well, what gets me how many do I have if I take 2/3 of 6? Now what we want to do now is apply that same idea, but to multiplying not a fraction times a whole number, but a fraction times a fraction. So let's say that we wanted to take 3/4, and multiply it by 1/2. And we know, of course, this is the exact same thing. The order that we multiply doesn't matter. This is the exact same thing as 1/2 times 3/4. 1/2 times 3/4. So to imagine where this gets us, let's draw ourselves a number line. So this is 0, and I'll do it pretty large so that we have some space to work in. So that's 0, and then that is 1, and of course our line could keep on going. And let's first imagine 3/4 times 1/2 as 3/4 of the way to 1/2. So first let's plot 1/2 on our number line. Well, 1/2 is literally halfway between 0 and 1. So that's 1/2 right over there. And how do we think about 3/4 of the way to 1/2? Well, what we could do is think about, well, what's 1/4 of 1/2? Well, we could divide this part of the number line into 4 equal sections. So that's 2 equal sections. Now that's 4 equal sections. And while we're at it, let's divide all of the halves into 4 equal sections. So let's divide all of the halves into 4 equal sections. So that's 4 sections. And now let's do this one. I'm trying my best to draw them equal sections. So I've taken each of the halves and I've made them into 4 equal sections. So this distance right over here, this gets us, or this point right over here, is 1/4 of 1/2. But that's not what we care about. We want to get to 3/4 of 1/2. So we want to get to 1, 2, 3/4 of 1/2. So this point right over here, this is literally 3/4 times 1/2. And this is, of course, 1/2 here. But what number is this? We can now visualize it on the number line. And let me do this in a new color. We can now visualize it on the number line. But what number is this actually? Well, a big clue is that, well, before we had the section between 0 and 1 divided into 2 equal sections when we only had to plot 1/2. But then we took each of those 2 equal sections and then split them into 4 more sections. So each of these, by doing that, we now essentially have divided the section between 0 and 1 into 8 equal sections. So each of these is actually 1/8. So this point right over here is 1/8. This is 2/8. And then this is 3/8. And that's in line with what we've seen about multiplying fractions before. This should be equal to 3 times 1 over 4 times 2. 4 times 2, which is equal to 3/8. Which is equal to 3/8. And everything that we're talking about, this all, so we don't get confused, this is all referring to this point right over here on the number line. This point right over here. But what if we thought about it the other way around? What if we thought about it as 1/2 of the way to 3/4? So we could divide the space between 0 and 1 into fourths. So let's do that. So that is 1/4, 2/4, 3/4. So this right over here is the number 3/4. And we want to go half of the way to 3/4. Well, what is half of the way to 3/4? Well, we split this section into 2 equal sections. So we could split right over there. We could split right over here. And we want to go exactly one of those sections. 1/2 of 3/4 gets us, once again, right over here to this point 3/8. So either way you imagine it, whether you're essentially taking 3/4 of 1/2 or saying, I'm going to go 3/4 of the way to 1/2, or you say, I'm going to go 1/2 of the way to 3/4, either way, hopefully it now makes conceptual sense. You can visualize it, and it makes numeric sense that this is going to be equal to 3/8.
We're asked to multiply 5/6 times 2/3 and then simplify our answer. So let's just multiply these two numbers. So we have 5 over 6 times 2 over 3. Now when you're multiplying fractions, it's actually a pretty straightforward process. You just multiply the new numerator, the numerator of the product, is just the product of the two numerators, or your new top number is the product of the other two top numbers. So our the numerator in our product is just 5 times 2. So it's equal to 5 times 2 over 6 times 3. Over 6 times 3, which is equal to 5 times 2 is 10, and 6 times 3 is 18. So it's equal to 10/18. And you could view this as either 2/3 of 5/6 or 5/6 of 2/3, depending on how you want to think about it. And this is a right answer. It is 10/18. But when you look at these two numbers, you might immediately see that they share some common factors. They're both divisible by 2. So if we wanted in lowest terms, we want to divide them both by 2. So divide 10 by 2, divide 18 by 2. And you get 10 divided by 2 is 5. 18 divided by 2 is 9. Now, you could have essentially done this step earlier on. You could have done it actually before we did the multiplication. You could have done it over here. You could have said, well, I have a 2 in the numerator, and I have something divisible by 2 in the denominator. So let me divide the numerator by 2, and this becomes a 1. Let me divide the denominator by 2, and this becomes a 3. And then you have 5 times 1 is 5, and 3 times 3 is 9. So it's really the same thing we did right here. We just did it before we actually took the product. You could actually do it right here. So if you did it right over here, you'd say, well, look, these are eventually going 6 times 3 is eventually going to be the denominator. 5 times 2 is eventually going to be the numerator. So let's divide the numerator by 2. So this will become a 1. Let's divide the denominator by 2. This is divisible by 2, so that'll become a 3. And it'll become 5 times 1 is 5, and 3 times 3 is 9. So either way you do it, it'll work. If you do it this way, you get to see the things factored out a little bit more. So it's usually easier to recognize what's divisible by what. Or you could do it at the end and put things in lowest terms. multiply 1 3/4 times 7 1/5. Simplify your answer and write it as a mixed fraction. So the first thing we want to do is rewrite each of these mixed numbers as improper fractions. It's very difficult, or at least it's not easy for me to directly multiply mixed numbers. One can do it, but it's much easier if you just make them improper fractions. So let's convert each of them. So 1 3/4. 1 3/4 is equal to, it's still going to be over 4. So you're still going to have the same denominator, but your numerator as an improper fraction is going to be 4 times 1 plus 3. 4 times 1 plus 3. And the reason why this makes sense is 1 is 4/4, or 1 is 4 times 1/4. Right? 1 is the same thing as 4/4. And then you have 3 more fourths. So 4/4 plus 3/4 will give you 7/4. Will give you 7/4. So that's the same thing as 1 3/4. Now let's do 7 1/5. 7 1/5. 7 1/5. Same exact process. You're still going to have, we're going to still be talking in terms of fifths. That's going to be the denominator. And when you take 5 times 7, because think about it, 7 is the same thing as 35/5. So you take 5 times 7, so it's 5 times 7 plus this numerator right here. So 7 is 35/5. Then you have one more fifth. So you're going to have 35 plus 1, which is equal to 36/5. So this product is the exact same thing as taking the product of 7 over 4 times 36 over 5. Times 36 over 5. And we could multiply it out right now. Take the 7 times 36 is our new numerator. 4 times 5 is our new denominator. But that'll give us large numbers. I can't multiply 7 and 36 in my head, or I can't do it too easily. So let's see if we can simplify this first. So both our numerator and our denominators have numbers that are divisible by 4. So let's divide both the numerator and the denominator by 4. So the numerator, we can divide the 36 by 4. We can divide the 36 by 4 and get 9. And if you divide something in the numerator by 4, you have to divide something in the denominator by 4. And the 4 is the obvious guy. So 4 divided by 4 is 1. So now this becomes 7 times 9. And what's 7 times 9? It's 63 over 1 times 5 over 5. So now we have our answer as an improper fraction, but they want it as a mixed number, or as a mixed fraction. So what are 63/5? So to figure that out, let me pick a nice color here. We take 5 into 63. 5 goes into 6 one time. 1 times 5 is 5. You subtract. 6 minus 5 is 1. Bring down the 3. 5 goes into 13 2 times. And you could have immediately said 5 goes into 63 12 times. But this way, it's at least to me, it's a little bit more obvious. And then 2 times 5 is 12. And then we have, 2 times 5 is 10. 2 times 5 is 10. It tells you not to switch gears in the middle of a math problem. 2 times 5 is 10. And then you subtract, and you have a remainder of 3. You have a remainder of 3. So 63/5 is the same thing as 12 wholes and 3 left over, or 3/5, or 3/5 left over. And if you wanted to go back from this to that, just think. 12 is the same thing as 60/5, or 60 over 5. 60 over 5 plus 3 over 5 is 63 over 5. So these two things are the same thing. These two things are equivalent. This is as an improper fraction. This is as a mixed number, or a mixed fraction. But this is our answer right there, 12 3/5. A recipe for banana oat muffins calls for 3/4 of a cup of old-fashioned oats. You are making 1/2 of the recipe. How much oats should you use? So if the whole recipe requires 3/4 of a cup, and you're making half of the recipe, you want half of 3/4, right? You want half of the number of old-fashioned oats as the whole recipe. So you want 1/2. You want 1/2 of 3/4. 1/2 of 3/4. So you just multiply 1/2 times 3/4. And this is equal to, you multiply the numerators. 1 times 3 is 3. 2 times 4 is 8. And we're done. You need 3/8. You need 3/8 of a cup of old-fashioned oats. And let's visualize that a little bit, just so it makes a little bit more sense. Let me draw what 3/4 looks like, or essentially how much oats you would need in a normal situation, or if you're doing the whole recipe. So let me draw. Let's say that this represents a whole cup, and if we put it into fourths, so let me divide it a little bit better. So if we put it into fourths, you put it into fourths. 3/4 would represent 3 of these. So it would represent 1, 2, 3. It would represent that many oats. Now, you want half of this, right? Because you're going to make half of the recipe. So we could just split this in half. We could just split this in half. Let me do this with a new color. So you would normally use this orange amount of oats, but we're going to do half the recipe. So you'd want half as many oats. So you'd want half as many oats. So you would want this many oats. This many oats. Now let's think about what that is relative to a whole cup. Well, one way we can do it is to turn each of these 4 buckets, or these 4 pieces, or these 4 sections of a cup into 8 sections of a cup. Let's see what happens when we do that. So we're essentially turning each piece, each fourth, into 2 pieces. So let's divide each of them into 2. So this is the first piece. We're going to divide it into 2 right there. So now it is 2 pieces. And then this is the second piece right here. We divide it into 1 piece and then 2 pieces. This is the third piece. So we divide it into 1, 2 pieces. And this is the fourth piece, or the fourth section. And we divide it into 2 sections. Now, what is this? What is this as a fraction of the whole? Well, we have 8 pieces now, right? 1, 2, 3, 4, 5, 6, 7, 8. Because we turned each of the 4, we split them again into 8. So we have 8 as a denominator. And we took half of the 3/4, right? Remember, 3/4 was in orange. Let me make this very clear, because this drawing can get confusing. This was 3/4 right there. So that is 3/4. This area in this purple color, is 1/2 of the 3/4. But let's think about it in terms of the 8s. How many of these sections of 8 is it? Well, you have 1 section of 8 here, 2 sections of 8s there, 3 sections of 8. So it is 3/8. So hopefully that makes some sense, or gives you a more tangible feel for what it means when you take 1/2 of 3/4.
You can ride your bike 1/5 of a mile per minute. If it takes you 3 1/3 minutes to get to your friend's house, how many miles away does your friend live? And here's pictures of these guys on bicycles. It's pretty clear they're not riding to work, or some of these guys aren't even riding a bicycle. But let's focus on the question. So you can ride your bike 1/5 of a mile per minute, and you're going to do this for 3 1/3 minutes. Times 3 1/3. So we really have to figure out, how do we multiply 1/5 times 3 1/3? So there's a couple of ways to think about it. You could literally view a 3 1/3 as, this is the same thing as 1/5 times 3 plus 1/3. That's exactly what 3 1/3 is. And then we can just apply the distributive property. This would be 1/5 times 3. 1/5 times 3. I'm going to keep the colors the same. Times 3 plus 1/5 times 1/3. Times 1/3. And this is going to be equal to, well, we could rewrite 1/5 times 3 as 1/5 times 3 over 1. That's what 3 really is if we wrote it as a fraction. And then, of course, we're going to have plus 1/5 times 1/3 times 1/3. And let's just think about what each of these evaluate to. Here, you multiply the numerators and you multiply the denominators. So this is going to be equal to 1 times 3 over 5 times 1. And this business right over here, is going to be, and remember, order of operations, we want to do our multiplication first. So this is going to be 1 times 1 over 5 times 3, over 5 times 3. And so that's going to be equal to 3 over 5 plus 1 over 15. And now we have different denominators here, but lucky for us, 3 over 5, if we multiply the numerator and the denominator by 3, we're going to get a denominator of 15. And so that's equal to 9 over 15 plus 1 over 15, which equals 10 over 15. And if you divide the numerator and the denominator both by 5, you're going to get 2 over 3. So your friend lives 2/3 miles away from your house. Well, that's kind of interesting, and this was kind of a long way to do it. Let's think about if there's a simpler way to do it. So this is the same thing as 1/5 times, and I'm just going to write 3 1/3 as a mixed number. So it's 1/5 times 3 1/3 can be rewritten as 9/3. Sorry, I'm going to rewrite 3 1/3 as an improper fraction. So this is the same thing as 9/3, that's 3, plus 1/3, which is the same thing as 1/5. Why, I switched colors arbitrarily, which is the same thing, I'm still on the same color, as 1/5 times 9/3 plus 1/3 is 10/3. And now we can just multiply the numerator and multiply the denominator. The numerator, or multiply the numerators. So this is 1 times 10. 1 times 10, I'm trying to stay good with the color coding, over 5 times 3. Over 5 times 3, which is exactly equal to what we just got. 1 times 10 is equal to 10. 5 times 3 is 15. 10/15 we already established is the same thing as 2/3. So your friend lives 2/3 of a mile away from you.